Alright, so good afternoon everyone. I welcome you back to my YouTube channel, and presenting before this tutorial is Hambe Kliman. And to those of you that are new to the channel, don't forget to subscribe and also hit the like button, and also don't forget to share. So if you have a question, don't hesitate, please inbox me on this WhatsApp line and I'll be able to respond to you. So we are doing an overview of chemical equilibriums. Okay, so chemical equilibrium, and I'm sure chemical equilibrium is quite going to be enjoyable to you, because it's a very simple topic. It's a very simple and straightforward topic. So please don't forget to subscribe and also enjoy my lesson even as I teach. So there's a question here, and the question is simply saying, suppose a reaction has the equilibrium constant K 1.3 multiplied by 10 to the power 8. What does the magnitude of this constant tell you about the relative concentrations of products and reactants that will present once equilibrium is reached? Is this reaction likely to be a good source of the products? All right, so let's get to the answer. But then, for us to answer this question, we will first of all look at our equilibrium constant. So our equilibrium constant is a very much positive value. So it is 1.3 multiplied by 10 and to the power 8. It's quite a very big value. Then we know that when we want to find equilibrium constant K, which happens to be Kc, we know that it is simply products over reactants. Now, this simply means that when the reactants increase, then the products, then the products, of course, might decrease, okay? But then the relationship which I want to create here is this relationship which is between Kc and products, because we know that Kc is directly proportional to the products, in that if this is our Kc and we have our products, increase in products will mean increase in Kc, and a decrease in product will mean a decrease in Kc. But in this case, we discover that our Kc is a very large value. What does that tell you? That simply tells you that your products are much more than the reactants. The rate at which the reactants are being used up, so we have the reactants, products. The rate at which the reactants are being used up is very high, and the rate at which the products are being formed is very high as well. So we are going to have less reactants on the left hand side of the equation, and much more products on the right side of the equation. So to answer this question, what does the magnitude of this constant tell you? The magnitude of this constant about the concentration simply tells us that we have much more products and less reactants for us to produce this large value. Is this reaction likely to be a good source of products? Of course. Why? Because the rate at which products are being formed is very high compared to the rate at which the reactants are being used up, of course. So you must be thinking in those lines in order to answer these very simple questions. Of course, we get to the second question and we'll try to use our understanding of chemical equilibrium. At a given temperature, K is equal to 1.3 multiplied by 10 to the power 2. Of course, this also tells us that the rate at which products are being formed, of course, is very high compared to the rate at which the reactants, whatever, and everything. Of course, it's just a simple concept. You can use the same concept I've used in the first question, and of course, it will give you the same value and answer. So, they're saying we calculate the value of K for the following reactions in this question. Okay, saying this temperature, of course. But then, how do you calculate constant K from a given constant K? And of course, this constant K is simply called K prime. We call it K prime, or you can use this symbol, K prime. It's just one and the same, K prime. So now to calculate K prime from this, I'm going to give you this formula. K prime for the first question is going to equal to the value of K to the power n. Now, let's ask ourselves, what is, I want for us to answer this question. Let me say for you to answer this question, I want you first of all to observe. Okay, so I'm going to write this, observe original equation. So, when you observe the original equation, nitrogen plus hydrogen producing ammonia, for the given reactions, they are the same equation as the original equation, except that they've been balanced, okay, differently. But then, you need to ask yourself, what number exactly were they multiplying to this particular equation for them to balance it this way? So here we had 3, but here it's 3 over 2. Here we had 2, but here it is just 1. So it simply means that if we multiply by 1 over 2, then it's going to be 1 over 2 multiplied by n, it will be 1 over 2n. This is the 1 over 2n. 3 multiplied by 1 over 2, it will be 3 over 2. 2 multiplied by 1 over 2, it will be 1. So they were multiplying by 1 over 2. So therefore, K is going to equal to K, then of course, what is my constant K? It is 1.3 multiplied by 10 to the power 2. And of course, my n is simply 1 over 2. Whatever value you are going to find, that is exactly the value of K prime for the first question. For the second question B, it's the same concept, but it has been flipped. It's the same equation. Nothing has been added except that it has been flipped. So in mathematics, whenever you're flipping something, it's the inverse of that particular thing. So of course, this is just 1 over K prime. So the previous equilibrium constant, the initial equilibrium constant to the power n. In this case, nothing has been added, so n is just 1. They multiplied by 1. So K is going to equal to 1 over, okay, let me just put it in this manner. It's not concentration anymore, it's a constant. Okay, like this. whatever value you get, then of course that is your final value. If you have enjoyed my tutorial, consider subscribing, and also don't forget to comment. Don't forget to share to others as well. Thank you so much.